Alright, so today I'm going to be teaching you how to make a Frogger remake in PyGame. In the end, it's going to end up looking something like this, where you have a frog and you can navigate through this maze of cars and logs and turtles. It's about 200 lines of code, so it's pretty simple. It uses skills that we've already learned in our club. So yeah, I'll be teaching you how to make this. So first we're going to set up our assets. Normally this is something you do towards the end of game development, but since all of our resources are pre-made, at least for the game that I'll be making, we're just going to get them from this website called the Sprites resource. It's a super cool website where you can access tons of sprites from tons of games. But I'm just going to go to the arcade tab and to F, and Frogger is right here. And I'll be clicking on this, and this is just the game sheet from the original Frogger game. It has every sprite that's used in the game. I'm just going to download this, and we'll be using this image. I'm just going to call it froggersheet.png, and we'll just be using all of these sprites to make our game. Okay, so you can use a resource like Paint 3D to open that sheet image and just trim out whatever sprites you're going to use. I made an assets folder, and we have a couple more folders inside this assets folder that contain all our sprites. But right here is the sheet that I used to get all the sprites, and this is going to be the background of our game. Inside these four folders, there's the sprites for the frog. I just have down, left, right, up. I have the sprites for the grass, just the green and purple grass. The sprites for the river, so inside the river I have left and right. Left is the turtle, right is the log. Left means it's going to be moving towards the left side of the screen, right means it's going to be moving towards the right. Same with the street folder, I have left for 2 cars and right for 2 cars. So yeah, once again, just use any paint editor or image editor to just get these images in their own PNG file. Okay, so I'm going to be using Visual Studio Code to make this. You can use whatever code editor you're comfortable with. To start, we're going to make a game loop. So I'm going to need to import PyGame and system, and then we're going to make a class called game. In the initialization function, we're going to need the dimensions of the screen, the caption of the screen, and the color of the screen. First, we're going to initialize PyGame, and we're going to do pygame.display.setModes, the dimensions of the screen, and pygame.display.setCaption as the caption of our screen. We're going to make a variable that stores our screen color, and we're going to make a variable called display, pygame.display.getSurface. I'm going to make a few sprite groups inside of our game class. These are going to store all the sprites we'll create and put on screen. So I'm going to have 4 of them. I'm going to have one called self.objectGroup. This will store the background, any objects that'll sort of be in the background behind our sprite. I'm going to have one called carGroup and riverGroup. These two are going to store any sprites that are in like the lanes of the street or the river that move across the screen. And finally I'm going to have a group called frogGroup, and that's just going to store our frog sprite. It's going to be at the very front of our screen, so it'll be above everything. And I'm just going to make a list called self.allGroups. This will just be a list storing all of our groups we just made. Now we're going to make a function called run, and this is going to be a while loop. First we're going to fill our display with our screen color. We're going to do a for loop that goes through every event in PyGame, and we're going to check if that event is a quit event. If so, we're going to quit PyGame and exit our program. Next, I'm going to make another for loop, and we're going to check for every group in our all groups list. For sprite in this group, we are going to update the sprite, and we are going to draw this group to the screen. Finally, at the end of this while loop, we are going to update our display. And now let's make an instance. We'll call it game. For the dimensions of the screen, I'm going to make it 672 by 768. In the original Frogger game, the dimensions are 14 by 16 tiles, and we're going to make each of these tiles 48 by 48 pixels. So we multiply 14 by 48 to get 672 and 16 by 48 to get 768. You can set the caption to whatever you want. I'm just going to call it Frogger. And the screen color I'm just going to set as black. And now let's run this instance, and we should have a screen just like this. Alright, now we're going to set up our sprites. So I'm going to make a new file called object.py. I'm going to import PyGame. I'm going to make a new class called object. This is going to be a subclass of PyGame.Sprite with a capital S on the second sprite. Some parameters we're going to need are the position of our sprite on screen, the size in pixels, the image directory, and the group that the sprite is in. From the PyGame.Sprite class, we're going to initialize our group. And we're going to make two variables storing our position and size, and one storing our image directory. I renamed these two variables to image directory just for convenience. Alright, now we're going to make a function called setImage. First we're going to create a variable called image, and it's going to be pygame.image.load self.image directory, this string right here. Next we're going to transform this image. We're going to scale it based on our size variable, so pygame.transform.scale. We're going to do self.image and then self.size. This does not need to be a tuple. Next we're going to create a surface for this image. We're going to call it self.surf. And this is going to be pygame.surface. It's going to be our size variable as well. Then we are going to do convert alpha, so if you have any transparent pixels, it will not be. And we're going to fill this surface with 0, 0, 0, 0, or just a transparent RGB value, so we can see these transparent, or I guess not see these transparent pixels. Now we're going to make a rectangle for this sprite. It's going to be called self.rect. We're going to do self.surf.getRect. We're going to set the top left pixel of our rectangle as the position that we input. So if we create an object and the position variable is 0, 0, it's going to be at the very top left of the screen. The top left corner of this sprite is going to be touching the top left corner of the screen. If you were to set this to center, which I would not recommend for creating this game, the center of the sprite would be at 0, 0. Next we're going to put this image on our surface we created. So we're going to do self.surface.blit self.image and just put 0, 0. Finally we're going to create a function called update, and this will just be self.setImage. So when we create an object, one of the parameters is going to be one of these groups that we created, and inside our run function we are updating every sprite in every group. So this update function is going to be useful for performing actions on our sprite. Alright, I'm going to create a new file. This is going to be called frog.py. We're going to import PyGame, and we're going to import everything we created inside of our object file. This asterisk means everything from a certain library. And we're going to create a class called frog. This frog class is going to be a subclass of our object class we just created, and it's going to help us create our frog sprite that the user will be able to move around the screen. First, our parameters. We're going to need a position, size, image, and group, just like our object class. And from our object class, we're going to initialize these size, position, image, and group variables. And this is all we need to do for our frog class right now. We're going to come back to it later and create certain functions so we can move our sprite around. But for now, you can go back to your main class, and we're going to create a new function called assetSetup. We're going to use this function to set up all of our sprites at the beginning of our game. I'm going to make a variable called self.frog, and it's going to be an instance of our frog class. Make sure that you import everything from your frog.py file. I'm going to set the frog's position at 336, 672. This is just a tile position on our screen that the sprite is going to spawn at. The size is going to be 48 by 48 pixels. All of our tiles are going to be 48 by 48 pixels, and our frog is the size of one tile. If we go into our assets folder, we have assets, frog, and then a bunch of sprite images for our frog. I'm gonna set the image directory of our frog as assets/frog/up.png, so it'll spawn facing up, which is the direction it's gonna want to advance in. And the group is gonna be self.frogGroup. At the end of our initialization function, we're gonna call this asset setup function, and when we run our program, we'll see a frog sprite at the bottom of our screen. I'm going to go ahead and set up the rest of our sprites in the background. Make sure this frog sprite is the last thing you're setting up, because inside this asset setup function, we're going to eventually make some changes to our frog sprite that are going to require some additional code above it. First, make sure to import everything from your objects class. This is what we're going to be using to create all of our background sprites. So first I'm going to create an object. Its position is going to be 0, 0. Size is going to be the size of the screen, so 672 by 768. And its image directory is going to be assets/background.png. This is just going to be the background of our game. And its group, all the objects I'm going to be creating are going to go into our object group. When we run our game, we should see a background. Next, I'm going to set up some grass. So the game has a strip of green grass going across the screen right about here, a strip of purple grass right here dividing the road and the river, and another strip of purple grass that I should be standing on right now. The goal is to reach the green grass. So starting with the purple grass that I'll be standing on and that divides the river and the road, since our screen is 14 tiles in length, I'm going to need 14 tiles of purple grass growing across the screen. So I'm going to do a for loop for x in range 14. I'm going to create an object. Its x position is going to be this x value times 48. And for the first strip of purple grass, its y position is going to be 384, 48 by 48 pixels in size. And its image directory is going to be assets/grass/purple.png, and add its group as object group. For our second strip of purple grass, I'm just going to copy and paste this, except our y position is instead going to be 672. So when you run your game, you'll have two strips of purple grass, one which you'll be standing on. So if you noticed in the game sheet, the green grass is a little bit weird. Instead of being one tile in width and one tile in height like the purple grass, it's instead half a tile in width and 1.5 tiles in height. It's not a problem though. Instead of 14 pieces, or I guess tiles of this grass, we're instead going to need 28, which is double. We're going to create an instance of our object class. And this x value is going to be instead multiplied by 24. And our y value is going to be 72 for all of these. Our size, instead of 48 by 48, it's going to be 24 by 72. And our image directory is going to be assets/grass/green.png. And set the group as object group. And when you run your game, you'll have a strip of green grass at the top of your screen. So now you can kind of see we have a river right here and a road right here, and we're going to want cars to go across this road and logs and turtles to go across this river. Before we do this though, we're going to create a function to move our frog sprite. So one thing we're going to need is a list called keyups. This is going to store all the keys that have just been released by the user. We don't want to move the frog when a key goes down, we want to move it when the key has been released by the user. To get all of the keys that have been released by the user, first inside of our run function, at the start of every loop, we're going to set the frog's keyups list to empty, and inside of our event loop. We're going to do if event.type equals PyGame.keyUp self.frog.keyups.append the event.key. So this will create a list inside of our frog class that stores every key that has just been released by the user. Inside our frog class, I'm going to create a new function called moveFrog. At the start of this function, I'm going to get an x and a y value that store the x and y value of our frog. And so there are 4 directions our frog sprite can move. It can either move up, down, left, or right. So I'm going to check every one of these directions using the arrow keys. So if PyGame.keyUp, this is the up arrow, is in self.keyups. So if this up arrow key is inside this self.keyups list, we're going to move our sprite up. So we're going to set the image directory of our sprite to assets/frog/up.png because we want our sprite to be facing the direction it just moved in. And we're going to subtract 48 from our y variable. Repeat this for the rest of your directions. Now I'm going to set our position variable to a tuple containing our x and y variables, and I'm going to recreate the update function. We're going to first set the image of the sprite, and we're going to call the moveFrog function. I'm going to create one more function. This is going to be called killFrog. There are a couple ways your frog can die, either if it falls in the water, is hit by a car, or the only options we can do right now if it moves off screen. So inside this killFrog variable, we're going to set the position back to 336 and 672. This is the spawn point for our frog. We're going to set the image directory to be facing up again, and we're going to set the image of our sprite. So inside our move function, I'm going to create an if statement. If our x value is less than -48, this is off the left side of our screen. Or if the x value is greater than 48 times 14, this is off the right side of our screen. Or if the y value is greater than 48 times 16, this is off the bottom of our screen. Then we're going to kill our frog and return. So just end this function entirely before we set the position variable. Now when we run our game, we can click the up arrows on our keyboard, or the left or the right or down arrows on our keyboard, and our sprite will move in whichever direction you click. Alright, now let's actually start creating the obstacles that'll move left and right across the screen that the player either has to dodge or jump onto. So I'm going to create a new file, and it's going to be called lane.py. I'm going to import random and PyGame, and I'm going to create a class called lane. Some parameters we're going to need for this function. I'm going to need the position of the lane, the group that all the sprites will be stored in, the speed that the obstacles in the lane move at, and the type of lane. This is either going to be a street lane or a river. Let's just create some variables for all 4 of these parameters. Now I'm going to create a new file called obstacle.py. I'm going to import PyGame, as well as everything from our object.py file. You know, this is what we use to create our sprites. And I'm going to create a class called obstacle. And this is going to be a subclass of our object class, as well as all our default parameters, you know, our position, size, image, and group. I'm also going to need a speed variable. This speed variable will store how fast or slow the sprite moves across the screen. And as always, initialize these first 4 variables from our object class. Create a variable for your speed. So in total there's 10 lanes in this game, and inside of our asset setup I'm going to create these lanes. Inside of our main file, import random, and we're going to create a list that stores all the potential speeds of our lanes. I'm keeping these numbers low and increasing or decreasing by 0.25, so negative 1.25, negative 1, negative 0.75, negative 0.5, negative 0.25, and then 0.25, 0.5, 0.75, 1, and 1.25. A negative value means it'll be moving towards the left side of the screen, and a positive value means it'll be moving towards the right side of the screen. 1.25 is the highest value. This means it'll be moving fast, and a 0.25 means it's pretty slow. These are somewhere in between. I'm not using a random.randInt function to generate our speeds because I want all the lanes to have varying speeds. So I want to make sure that none of the lanes are moving at the same speed. And I'm going to shuffle these speeds, so random.shuffle speeds, so they're in the list is in a random order. So this is going to be our river lanes. I'm going to do 4 y in range 5, since there's 5 river lanes. The y position of this lane is going to be the function, the y variable times 48 plus 144. Make sure to import, and I'm going to create an instance of my lane class. The position is going to be 0, and the y position variable we just made. The group is going to be self.riverGroup. The speed is going to be speeds.pop. So it's going to pop the last value from the speeds list, and it's randomly shuffled, so this will create a random speed. And the lane type is going to be called river. Now for our street lanes, I'm going to do another for loop and another y position variable, except this one's going to be y times 48 plus 432. And I'm going to create an instance of our lane class again. The position is 0 and our y position. It's going to be in self.carGroup. Pop another value from speeds. And the lane type is called street. So there's nothing actually displayed on screen, but now we have 5 river lanes that sort of exist right here and 5 street lanes that exist here. We're going to use these lanes to spawn logs, turtles, and cars that move across the screen. One small addition I'm going to add, which is going to be beneficial when we're creating collisions for our sprites. I'm going to create a dictionary in our initialization function of our game class. It's going to be called river speeds, and this is just going to store all the speeds of our river lanes. So I'm going to just assign this lane instance a variable. I'm going to call it new lane. I created this reference image that just displays how our tile system works. So you can see it's 14 by 16 tiles. Since it starts at 0, it's technically 13 by 15. So our river lanes are 3, 4, 5, 6, and 7. Our street lanes are 9, 10, 11, 12, and 13. So for our river dictionary, the key is going to be the lane number. So if I set the key to y position over 48, the 5 keys are going to be 3, 4, 5, 6, and 7. And then the value is going to be set to this new lane's speed. So the new lane variable, the instance of our lane class, the speed of it. Inside our lane class, I'm going to create a new function called setUpObstacles. So inside this function, we're going to set up all the obstacles that will spawn in our lanes. For the street lanes, I'm going to have 3 cars per lane. For the river lanes, I'm going to have 2 logs or 2 groups of turtles per lane. First, I'm going to do an if statement. If self.speed is greater than 0, I'm going to create a variable called direction, and it's going to be set to right. This means the sprite is moving towards the right. But if it's not positive, if our self.speed variable is negative, we're going to set the direction variable to be left. First, I'm going to set up some obstacles for the street. So we're going to check if the lane type is street. The car is going to be a random integer, either 1 or 2. There's 2 different cars that move left, and there's 2 different cars that move right. So this random integer is just going to determine which sprite is going to be in each lane. And we're going to create a variable called image directory. This is going to be the image directory of the sprite in each individual lane. So it's going to be assets / self.laneType. Assets, and then either river or street. / self.direction, either left or right, and then /car. So for street, it's either going to be 1 or 2.png. Now I'm going to create an instance of our obstacle class. Make sure to import everything from your obstacle.py file. The position of the car is going to be the position of our lane. The size is going to be 48 by 48 pixels. The image is going to be our image directory. The group is going to be whatever group we put as a parameter to our lane. So it'll either be our car group or our river group. And the speed is going to be whatever speed was put into our lane parameter. And we're going to call set.image off of this instance of our class. We're going to call this function inside of our initialization function, so just call this right here. And when we run our game, we should see 5 cars in our car lanes, all on the very left of our screen. So since I said I want to do 3 cars per lane, we're just going to add those real quick. I'm going to copy this and paste it 3 times, but I don't want them to be in the same position. So I'm going to do our position tuple is actually going to be self.position 0, or our x value. We're going to add 5 times 48 to the x value of our position. So this is going to move this second car 5 tiles to the right. And then our y value is going to stay the same, so self.position 1. And you can do the same thing for this third obstacle. We can replace self.position with this new tuple we made, except I'm going to do 10 times 48 instead of 5. So now when we run our game, you'll see 5 rows of 3 cars. Now let's do the same thing for our river. We're going to do if self.laneType is equal to river. First, we're going to check if self.direction is left. If it is, we want our sprite to be a turtle. And since our river obstacles are in groups of 3, like it's not just one obstacle moving across the river, it's a group of 3 moving across the river, I'm going to need 3 variables, and I'll explain why. These variables are just going to be the left, middle, and right of this group. For the turtle, they're all going to be the same image. This variable is basically the same as image directory, except there's 3 of them. We use the same one for all 3 of our obstacles right here, but we're going to need 3 different ones for the 3 obstacles we'll make down here. So the turtle is easy. All of the turtles have the same image to be in a group. Or all of the turtles in a group are the same image. It's just assets slash self.lane type slash self.direction slash turtle.png, and you can copy and paste this 3 times. It's a little more complicated if our sprite is moving to the right, because our sprite is going to be a log. Once again, we're going to make a left, middle, and right variable. But each of these are going to be a little bit different. It's still going to be assets slash self.lane type slash self.direction. But for the first image, it's going to be left.png. You can copy and paste this. For the second one, it's going to be middle.png. And for the right one, it's going to be right.png. You can see inside of our assets folder, there's 3 different images for the log, and this creates a group of 3 images that create an entire log. For the turtles, it's just the turtle copy and pasted 3 times, so it doesn't need to be connected in any way. Now that we have all 3 of these image directories, we can create some instances of our obstacle class again, and we can actually copy and paste this entire thing, and paste it right here. One small adjustment we're going to make, instead of 5 and 10, we're going to do just 0, 48, and then 2 times 48, which I believe is 96. This means all 3 of these sprites are going to be next to each other, creating a group of sprites. And since I said I wanted 2 groups of sprites in our river lanes, I'm going to copy and paste this. But instead, it's going to be at lane position 9, lane position 8, and lane position 7. You can just copy and paste this self.position tuple and set it to 7. So now when we run our game, one last thing, we can't leave this as image directory, since our image directory variables are instead left, middle, and right. So set them as left, middle, and right. And now when you run your game, you'll see groups of turtles and logs. And you can see these logs are seamless, they're not spread apart, it looks like a log, except it's actually just 3 sprites next to each other. Same with the turtles. And so these logs will be moving towards the right, and these turtles will be moving towards the left. Now we're going to move the obstacles in these lanes based on the speed variable. So in our obstacle class, create a new function called moveObstacle. We're going to create an X and a Y variable just like in our frog class. This is going to be self.position 0 and self.position 1, so our X and our Y variable. We're going to add our speed variable to our X value. So X plus equals self.speed. But obviously, if we keep this sprite moving forever, it's going to go off screen and we're going to lose our sprites. So first we're going to check if this X variable is greater than 48 times 15. Or this is the length of our screen. If it is, we're going to set the X variable to negative 48. This is just past the left side of our screen. That way we're not spawning it at 0 and it looks like our sprite just teleported to the front. It moves in from the side. This way it looks like we have an infinite flow of logs going across our screen, or cars, or whatever obstacle it is. So this is for sprites that move to the right. Now we're going to check if the X value is less than 48 times negative 2. This is off the left side of our screen. If it is, we're going to set the X variable to 48 times 14. so it spawns just past the right side of our screen. And finally, we're going to set our position variable to the x and y values. Now create your update function again, because we're going to be editing it. We're going to set the image of our sprite and call this move obstacle function. And now when you run your function, you're going to see all your sprites moving across the screen. And if we watch, say, this car right here, once it goes off screen, it's going to reappear on this side. It doesn't look like it's teleporting back to this side. It looks like a continuous flow of cars going across the screen. Now the only thing left we have to do is update our frog based on the collisions. Your frog wants to avoid the cars. When it hits a car, you want to kill it and send it back to the beginning. But if your frog hits a log or a turtle, it wants to hop onto this log and move with it. So it'll kind of hop onto this log and like move sort of like this with the log. But if it falls in the water, or if it doesn't collide with a log or a turtle, it's going to die and it's going to be sent back to the front. Or back to the start. So in our frog class, I'm going to create two more variables. One's going to be called collision groups, and one's going to be called river speeds. Collision groups is going to store all of the groups the sprite can collide with, and river speeds is going to store that dictionary we just created earlier. Create variables for these parameters, so collision groups equals collision groups, river speeds equals river speeds, and we're going to create one more new variable called x speed. We're going to set this equal to 0. This is going to be used when we're standing on a log or a turtle. We're going to move across the screen with that log or turtle. We're just going to update our frog instance back in our main file in our game class. This is what I mentioned earlier. Just create a list, and inside this list, it's just going to contain our car group and our river group, and then our river speed dictionary. In our frog class, I'm going to create a new variable called, not a new variable, I'm going to create a new function called check collisions. First, I'm going to set the image of our sprite, and this is very important. This algorithm is not going to work if you don't first set the exact location of your sprite. This variable is going to store a true or false value based on if the sprite is colliding with anything. So if your frog is colliding with something, this is going to switch to true. But by default, it's false. And we're going to do a for loop. We're going to do for sprite group in our self.collisionGroups variable, or our list. And if there is any collision, so if PyGame.Sprite.Sprite collide any, for self is the frog or these sprite groups, so if there's any collisions detected, we're going to set this collided variable to true. But if nothing happens, it's going to stay as false. I'm going to create a variable called lane. This is going to be our y position divided by 48, and this is going to store the lane that we're in. Or if our lane variable is like 5 times 48, if we divide that by 48, it's going to be 5, so the program knows we're in the 5th lane. We're going to make an if statement, so if collided is true, we're going to check if our lane is less than 8. If our lane is less than 8, that means we're in the river. So if we're colliding with something and we're in the river, that means we're either on a log or a turtle. So we're going to set our x speed to self.riverspeeds, whatever lane we're in. So if the river speed is 0.25, our x speed is going to become 0.25, and we're going to be moving at the same speed as that river lane. But if we collide with something and we're not in lane 8, which means we're in the street, that means we've died. So we're going to do self.killFrog. One more thing, inside of our kill frog function, we're just going to reset our X speed. Because if we're on a log and we die, we don't want to be still moving, we want to stop the X speed movement, and we're just going to be stationary. If we're not colliding with an object, so if we're not colliding with a car or a log or a turtle, we're going to set our X speed to 0. Because if we're not colliding with a log or a turtle, there's no way we'll be moving left or right across the screen. And if our lane is less than 8, we're going to kill our frog. So if we're not colliding with anything and we're in the river, that means we're in the water. And if the frog's in the water, it dies. So we're going to kill the frog. So go into your update function, and after self.moveFrog, we're going to call self.checkCollisions. And now if you run your program, we are so close to being finished. So we have all of our objects moving across the screen. If we walk into the road and a car hits us, we'll be sent back to the start. Let me see if I can get through this. And if we're at the river, if we fall in the river, we'll be sent back to the start. If you jump onto a log or a turtle, you won't die. The only thing is, we're not moving with the log yet. So the last thing we'll need to do is create some lines of code so that we move with this log. And this is really simple. We're just going to go to our frogs class, we're going to go to our moveFrog function, and right before it checks our X position, we're just going to add our X speed to our X variable. Obviously, if this X speed is 0, our X variable isn't going to be affected. We're not going to be moving left or right. But if this is the speed of one of the lanes of our rivers, then we're going to move with the log or turtle that we're on. So now when we play our game, and we get to the river, if you hop on a turtle or a log, you'll start to move with it. And if you hop off, I was just barely on the log right there, but if I decide to jump off of these turtles, I'll die. So you've essentially finished your game. You can do whatever you really want with this. If there's any other additions you want to make, like limited lives or a score system, you can go ahead and do that. This is a very basic tutorial. Once you get to the grass, you're going to be sent back to the start. That's just because it thinks you're falling in the water. But that's essentially what happens in the original Frog game. If you reach the grass, or I guess it's like the water pools, you gain points. So maybe you could detect if you're in this lane, you get some points. But yeah, from here you're really free to do whatever you want. This is the most basic version of Frogger you can create. So yeah, I hope this helped you if you were struggling with creating this project, and I'll see you at our next club meeting.